Hello. Yeah. In the previous class, we learnt about lubrication. What is a lubricant? What are the functions of lubricant? What are the important properties of lubricant? These are the things that we saw. In continuation with that, let's look at the classification of bearings. So, depending upon the direction of load applied, we have got radial bearings and thrust bearings. So, radial bearings essentially will have load applied in radial direction. So, this is the shaft and this is the bearing, which is this is the moving element, that is called journal, and this is the fixed element, or it's called bearing, and load comes radially onto the journal. Whereas in case of the thrust bearing, so this is the moving element, this is the fixed element over there, and then this is the load in the axial direction. Okay, such axial directed loads will act on thrust bearings, whereas in radial bearings, load will act perpendicular to the axis, or it will be acting on the journal. Okay, and then depending upon the nature of contact, we have got sliding contact bearings and rolling contact bearings. In sliding contact bearings, so you will have one moving element and you will have fixed element, as we saw here. So moving element is called journal and stationary element is called a bearing. Now let's look at the rolling contact bearings. So you will have steel balls, you will have inner ring, and this is the outer ring. Inner ring will be normally moving element, and outer ring is the fixed element. And then coming back to journal bearing, it's a type of sliding contact bearing wherein you will have a journal or a shaft which is rotating and surrounded by a bearing which is essentially stationary. Between bearing and journal, you will have fluid around them to avoid metal to metal contact between journal and bearing. Now let's look at the mechanism of lubrication. So essentially there are 5 types of lubrication mechanisms. One is a sliding with a thick film or fluid film lubrication, sliding with thin film lubrication or boundary lubrication, extreme boundary lubrication, zero film lubrication, and lastly it is hydrostatic or externally pressurized lubricating bearings. So in case of thick film lubrication, okay, the film of liquid lubricant is so thick that metal to metal contact does not exist. The metal to metal contact is totally avoided or prevented in case of thick film lubrication. So when there is no metal to metal contact between journal and bearing, so life of bearing will be more and its load carrying capacity will also be more. Whereas in thin film lubrication, when the velocity is too low, the oil film will not be capable of supporting the entire load, and there can be bearing which operates under this condition is said to be operating under thin film or boundary lubrication. So with boundary lubrication, load bearing capacity is too low. Okay, and then this can happen, that is thin film lubrication can happen when bearing load is quite high, and when shaft rotation is too low, then the metal to metal contact, that is the between journal and bearing, you will have very thin layer of fluid present. Normally this may further lead to metal contact. Next is extreme boundary lubrication. So under certain load and temperature condition, lubrication will fail to avoid metal to metal contact. This condition is called boundary lubrication. Under these conditions, seizure of metallic surfaces and destruction of one or both surfaces can happen. Okay, normally such things happen at spots called hot spots. If you see, there is very close, the metal to metal contact is quite close. So at hot spots, localized temperatures rises to such a degree that welding of metals take place. This is called extreme boundary lubrication. Next comes zero film lubrication or zero film bearings, which operate without any lubricant present. Okay, so normally they are called air bearings, where air itself between journal and bearing would operate as the lubricant. Next comes externally pressurized lubricated bearings. So hydrostatic bearings are those which can support steady load, wherein the fluid will be forced from external equipment, that is a pressurized fluid is forced between the journal and bearing. They are called hydrostatic or externally pressurized lubricated bearings. Next, it's important for us to know few terminologies and the pressure development in oil film in case of a journal bearing. So as we know, journal bearing is a sliding contact bearing wherein you will have a rotating journal, stationary bearing. Between bearing and journal, you will have fluid present around them. So in the figure A, if you see, the journal is at rest and then you will have fluid and the bearing. So there will be metal to metal contact in the beginning before it starts operating. As the journal starts rotating, it slightly climbs up in the opposite direction. Okay, that is indicated by line BLO here. Okay, so then you will have two films present, that is one is converge, and as the speed of the journal increases, so it flows down and then moves to opposite direction, and then you will have presence of convergent film and divergent film. As the speed of the journal further increases, the pressure that is developed in the convergent film of oil, that is at this zone, the pressure of oil increases. This high pressure oil will separate the journal from bearing, thereby avoiding metal to metal contact. So this zone is called convergent film, and as the fluid comes out of this, the pressure of the fluid drops over here, and that is called divergent oil film. Okay, so you'll have convergent oil film where the fluid will flow at a very high pressure, separating journal from bearing and avoiding metal to metal contact. And after that, when it comes out of the film, when it comes out of this journal and bearing, the pressure of the fluid will drop, and that film is called divergent oil film. The gap between journal and bearing at this junction is called minimum oil film thickness, denoted by H minimum. So this is how pressure development takes place in case of hydrodynamic lubrication. That is, dynamic action of fluid will ensure that there is no metal to metal contact during operation of journal and bearing. So this is how pressure development takes place in case of a journal bearing. And now let's look at the various materials that are used for bearing. One is the Babbitt material, bronze, cast iron can be used. And now let's look at various properties of bearing materials. Essentially, you can remember it by CFCE BCT. That is compressive strength. Bearing material should have high compressive strength. Fatigue strength, of course, for all the components that are used for developing automobile or machine, the fatigue strength of the material is very, very important. Then conformability. So the material should to accommodate shaft deflection. That is, the bearing material should accommodate shaft deflection during operation. Embeddability is the material should accommodate small particles of dirt or grit between them without scoring the material of the journal. That is, the material should be so strong enough that the presence of dust and grit should not create scoring on the surface. Then comes bondability. So by many bearings are made out of bonding one or more thin layers of bearing material to a high strength steel shell. So the strength of bond or bondability is an important consideration in selecting bearing material. Then corrosion resistance. As usual, if the bearing is operating in corrosive environment, the material should have very good corrosion resistance property. And then thermal conductivity. As we know, all the components which are subjected to friction, there is going to be change in or rise in temperature. The bearing material should be capable of withstanding those high temperatures. That means it should have high thermal conductivity so as to permit the rapid removal of heat generated by friction. And finally, the thermal expansion property. The bearing material should have low coefficient of thermal expansion. That is, it should not expand for a reasonably wide range of temperature. Okay, that means there should not be undue change in clearances because of temperature. So that is thermal expansion. That means it should have low coefficient of thermal expansion. So these are all the properties of any, that is desirable properties of bearing materials. Again, coming back to the general bearing, let's understand few terms used in hydrodynamic general bearing. So as we have discussed now, this is the journal, which is a rotating element. This is the bearing, which is a stationary element. Between journal and bearing, you will have fluid present around it. And the minimum distance between journal and bearing is called minimum film thickness. And here, the capital D represents diameter of the bearing, small d represents diameter of the journal, and L represents length of journal and bearing. Now let's look at the diametral clearance. It is basically the difference between diameters of bearing and the journal. That is called diametral clearance, that is given by CD. So D minus D will give you diametral clearance. So accordingly, radial clearance is going to be D minus D by 2 will give you radial clearance. Next comes diametral clearance ratio. So it is the ratio of diametral clearance D minus D to the diameter of the journal. That is called the diametral clearance ratio, denoted by xi. Then let's look at the eccentricity. It is the radial distance between bearing center and displaced center of bearing under the load, denoted by E. That is, during operation, center of journal is different, center of bearing is different. So difference between these two centers is called the eccentricity. Then minimum oil film thickness. So just now we discussed, it is the minimum distance between bearing and a journal under complete or thick film lubrication condition. So we have understood just now 10 minutes back that thick film lubrication is a condition where there is no metal to metal contact during running. So the thick film of lubrication film is so thick that there is no metal to metal contact. That condition is called thick film lubrication. And next is attitude or eccentricity ratio. It is essentially ratio of eccentricity of to the radial clearance. Eccentricity is the difference between centers of journal and bearing, and then this is the clearance. Okay, and then 1 minus 2 H naught by C will give you the eccentricity ratio or attitude. Then let's look at what is short and long bearing. So L by D ratio, essentially ratio of length to diameter of the journal. If it is less than 1, then we call it a short bearing. If L by D ratio, that is length to diameter ratio, is greater than 1, then we call it as long bearing. If it is equal to, that is length of journal is equal to diameter of the journal, which is the normal case, then such bearing is called a square bearing. Fine, let's recap what we have learnt now. Essentially, we learnt about classification of bearing, that is radial bearings and thrust bearings. Radial bearings are subjected to radial load, thrust bearings are subjected to axial load, and then we'll have sliding contact bearings and rolling contact bearings. And rolling contact bearings, we have learnt about it sufficiently in our previous discussions in the class. And journal bearing essentially consists of a journal and a bearing surrounded by fluid around them. Then we learnt about mechanism of lubrication, where you will have thick film lubrication, thin film lubrication, extreme boundary lubrication, zero film lubrication, and pressurized lubricated bearings. So thick film lubrication, no metal to metal contact. Thin film lubrication would occur during the starting of the journal bearing, and also when the shaft rotation is too low and when bearing load is too high, then thin film or boundary lubrication would occur. Then comes extreme boundary lubrication, where there are some spots called hot spots, where because of higher temperature, seizure would occur at such hot spots. Then in zero film bearings, there is no presence of the lubrication between the surfaces. Air may act as a lubricant. And in hydrostatic or externally pressurized lubricated bearings, we will have a pump which supplies the fluid at a high pressure. Then we learnt about pressure development in an oil film, static condition. As the journal starts rotating, still it climbs up in the opposite direction, and still metal to metal contact exists. As the speed of the journal further increases, there is going to be the convergent film and divergent film. This convergent film, because of high pressure that is developed in convergent film, it will push the journal out of the bearing surface, thereby creating or inducing thick film lubrication between them. And the convergent film will have high pressure lubrication with separate journal from bearing, and after that the pressure drops over here, that is called divergent film. Then we learnt about various materials that are used for bearings, such as Babbitt material, bronze and cast iron, and then various properties of bearings like compressive strength, fatigue strength, conformability, embeddability, bondability, corrosion resistance, and thermal conductivity and thermal expansion. Okay, these are the properties that we learned. And then terms used: diameter of the bearing, diameter of the journal, length of the journal. Then we learnt about few properties, few terms: diametral clearance ratio, eccentricity, minimum oil film thickness, eccentricity ratio, short and long bearings.